All right, so picture the scenario. You're deep in the zone. It's a maybe 2:00 a.m. The caffeine is just about wearing off.
Oh, I know this feeling all too well.
Right. But the code is finally flowing. You're building this great new command line tool, or I don't know, a prototype for a mobile app.
Yeah.
And then you hit the wall, the data wall.
It's that moment every developer just dreads. You realize you need to store state.
Exactly. Just simple stuff. You need to save some user settings, a local cache, whatever. But suddenly your brain just spins up into this full-on sysadmin mode.
Yeah, do I need Docker? Do I need to install Postgres? Am I really about to set up connection pools just to save a string?
It's like trying to kill a fly with a...
With a bazooka. Yeah,
Yeah.
that is the perfect description. It's infrastructure paralysis.
Right. And the answer is usually, fine, I'll just write it to a JSON file and, pray. But today we are doing a deep dive into the actual solution, the hero for this problem. It's probably on the phone in your pocket, definitely in your browser. We are talking about SQLite.
The little database that could. Or, as I sometimes think of it, the dark matter of the software universe. It's everywhere, holding things together, but you almost never see it.
So let's start with that elevator pitch you always hear, but I want to just take it apart. The definition is a self-contained, serverless, zero configuration, transactional SQL database engine.
It's a mouthful. It really sounds like buzzword bingo, doesn't it?
It really does.
Ah.
Especially serverless. Because, it's 2024. When I hear serverless, I immediately think of the cloud. AWS Lambda, functions, billing by the millisecond. But that's not what this means at all, is it?
Not even close. And that's really the first big mental hurdle to get over. When the creators of SQLite say serverless, they're being incredibly literal. They mean no server.
Not someone else's server.
No server. There's no background process, no MySQL or Postgres.exe running in your task manager listening on a port. Nothing.
Okay, so if there's no process running, how is it a database? Like, who's answering the phone when my app calls?
You are. Your application is. This is the self-contained part. SQLite isn't some separate program. It's a C library. You literally link that code into your application.
Whoa, okay.
So when your app makes a query, it's not sending a network packet over a TCP connection. It's just making a direct function call right inside its own memory.
So with a normal database like PostgreSQL, my app sends a query. It goes over the network, even if it's just local host. The server does its thing, sends the data back. But here, I'm just calling a function.
Exactly. It's the difference between, say, emailing a colleague to ask for a file versus just reaching to the filing cabinet right next to your desk. The latency is almost zero.
That explains so much about why it feels so snappy. But let's rewind a bit. Where did this thing even come from? Because linking a library sounds like something a lone hacker came up with. But this is an industry standard.
Well, the origin story is actually incredible. It goes back to the year 2000. A developer, D. Richard Hipp, was working on damage control systems for the U.S. Navy.
Wait, for the Navy?
For guided missile destroyers,
Yeah.
specifically. Yeah. And they're running this big database on board, and it was just a nightmare. The server would crash, the ship's network would get flaky, and suddenly the whole system couldn't access its data.
Not ideal on a warship.
Not ideal at all. So Hipp decided he needed something that didn't require a sysadmin to babysit it. He wanted a database that was as reliable as a simple file, but, could be queried with SQL. So he just wrote SQLite.
Okay, that raises the stakes a little. If it's good enough for a destroyer, it's probably good enough for my to-do list app.
You would hope so. And that military-grade reliability is really why it became so popular.
Yeah.
It wasn't built to be cool. It was built to just not break.
Let's talk about the zero configuration part then, because usually zero configuration really means it works until you touch it, and then it breaks forever.
Right. No, in this case, it really means plug and play. Because it's just a library, there's no installer, there are no permissions to set up, no users or roles to manage. You just include the library in your code. You say, open this file, .database.db.
And if it's not there...
It creates it. If it is there, it opens it. That's it. You're done.
Which brings us to the physical part of this. The single file, this part still blows my mind. The whole thing, all the tables, the indexes, the data, it's all just one file on your hard drive.
Just one single file. The standard path.
But hang on. Just a file sounds fragile. And it sounds like it wouldn't be portable. If I make a database on my MacBook, which is ARM, Mac OS, and I copy that file to, say, a Windows server running on Intel, that's got to break, right? Endianness, line endings.
You would think so.
Yeah.
That is the classic binary portability nightmare. But that is one of SQLite's superpowers. The file format is completely cross-platform stable.
Seriously.
You can take that file from your Mac, email it to a friend on Linux, put it on a USB stick for a Windows machine, drop it onto an Android phone. It'll just work. Byte for byte, no conversion needed.
That is wild. I mean, moving a database usually involves pgdump, this massive text file, transferring it, then a restore command that takes hours. You're saying I can just drag and drop it?
Drag and drop. It's basically a document format. In fact, here's a fun fact for you. The U.S. Library of Congress recommends SQLite as a preferred format for long-term preservation of datasets.
Get out! The Library of Congress.
The Library of Congress, yes. Because unlike some proprietary format or a cloud service that could just disappear, a SQLite is stable, it's self-contained, it's well-documented. They see it as a digital artifact that'll still be readable in 50 or 100 years.
That completely reframes it. It's not a lightweight tool. It's a digital preservation vault.
Okay, but speaking of how it works, we have to talk about the elephant in the room for SQL purists. I've heard SQLite kind of plays fast and loose with data types.
Ah, yes. The infamous dynamic typing, or as the creators call it, manifest typing.
Right. So in a normal database like Postgres, if I say a column is an integer and I try to stick the word hello in it, the database yells at me, throws an error, but
SQLite just says, sure, why not?
That sounds terrifying. Why would anyone want that?
Yeah.
It's definitely a polarizing feature. The philosophy is that SQLite prioritizes flexibility. It looks at the value itself, not the container. So yeah, you can store a string in an integer column. For languages like Python or JavaScript that are also dynamically typed, it feels very natural.
But for anyone from a strict schema background, it must induce panic attacks.
Total panic. It feels like the database is just shrugging and saying, look, you're the boss. If you want to put text there, that's on you.
Okay.
But, and this is important, but they have added strict tables in modern versions. So if you really need that type enforcement, you can turn it on now. By default, though, it assumes you know what you're doing.
Okay, so it's flexible, portable, one file. But let's go back to that skepticism. Lightweight often feels like flimsy. If I'm building something real, I need to know the data is safe. What if the power cuts out mid-save? Is my single file just corrupted? Game over.
And this takes us right back to that military heritage. SQLite is ASIC compliant. Atomicity, consistency, isolation, durability.
We hear ACID all the time, but let's break that down. What does it actually do here? How does a single file survive a power outage in the middle of a write?
It uses something called a rollback journal, or more commonly these days, a write-ahead log. But the basic idea is atomic commit. So imagine you're updating a row. SQLite doesn't just go and overwrite the data in the main file.
Okay.
First, it writes down what it's about to do in a separate temporary safety file. And only once that safety file is fully written and secure on the disk does it even touch the main database file.
So if the power goes out halfway through writing the main file...
When the system reboots, SQLite sees that little safety file is still there. It realizes the operation never finished, and it uses it to roll back the main database to the state it was in right before you started. It's all or nothing.
So your data is either fully updated or totally untouched, never half broken.
Never. That's the atomic part. It is incredibly robust for something so small. It's designed to survive app crashes, OS crashes, power failures. Pretty much the only thing it can't survive is the hard drive physically melting. Fair enough. If the drive melts, we've got bigger problems. Okay, so we've been singing its praises for 10 minutes. Every hero has a kryptonite. We have to talk about the limits. Because I'm pretty sure Facebook is not running on SQLite.
Definitely not. And this is where that serverless architecture becomes a double-edged sword. Since there is no server managing all the traffic, concurrency becomes a bottleneck.
Concurrency, so doing multiple things at the same time.
Specifically, writing multiple things at the same time. Reading is mostly fine. You can have lots of concurrent readers. But by default, when one process wants to write data, insert a row, update something, SQLite has to lock the entire file.
The dreaded file lock.
Exactly. It's like a one-lane bridge. If a truck that's a write operation needs to cross, it puts up a slip sign. No one else can cross or even get on the bridge until it's done.
That sounds like a disaster for a web app. If you have 50 users trying to do things, 49 of them are just waiting in the default mode, yeah. And that's the reason people used to say, never use SQLite for websites. But, and this is a huge but that so many people still miss, that all changed with wall mode.
Wall mode, W-A-L. What's that stand for?
Write-ahead logging.
Okay.
And this completely changed the game. Remember that one-lane bridge? Wall mode basically builds a side road for readers. When you enable it, writers don't touch the main database file immediately. They just append their changes to a separate log file.
So the main file stays unlocked?
Exactly. The readers can keep looking at the main file, the old stable version of the data, while the writer is off to the side, jotting down its changes in the log. It means readers and writers no longer block each other.
That sounds like it pretty much solves the problem then.
It solves most of the problem for small to medium-sized applications. It raises the ceiling dramatically. You can handle a surprisingly high amount of traffic with wall mode on, hundreds of requests per second even.
So medium is actually pretty big,
Yeah.
but there's still a hard wall somewhere, right? When do I absolutely have to switch to Postgres?
The wall is high concurrency writes. Even with wall, you can really only have one writer at a time appending to that log. SQLite queues them up super fast, microseconds fast, but if you have a massive application, think Twitter, where thousands of people are hitting post in the same second.
The queue gets too long.
The queue gets too long, the application starts to hang, you start seeing database locked errors. That's your signal. If your app is write-heavy, with tons of concurrent users, SQLite is not the tool for the job.
So a blog, where it's mostly people reading, SQLite is perfect.
Perfect. Even a pretty busy blog.
An IoT device logging data once a second.
Perfect.
A social network with 100,000 active users all posting at once.
Yeah, probably time for Postgres. It's about right-sizing the tool. You don't use a semi-truck to bring your groceries home, but you don't use a bicycle to move a grand piano. SQLite is the best bicycle in the world. Maybe an e-bike. But it's not a truck.
I love that analogy, and I think that's why it's so dominant in mobile apps. On my phone, I am the only user. There's zero write concurrency.
It's exactly right. For a mobile device or an embedded system, SQLite has no competition. It is the standard. If you're building a local first app, you don't need a server. You need a file.
There's one other use case I want to touch on because it goes back to that data wall we started with. Data analysis. I've seen a lot of data scientists using SQLite not as an application database, but just as a better CSV file.
Oh, this is a huge trend. Some people call it SQLite as a document. If you have a massive CSV file, millions of rows, trying to open that in Excel is just a nightmare.
Yeah, your lamb just dies.
Exactly. But if you import that into a SQLite file, which takes seconds, you can suddenly run powerful SQL queries against it. You can aggregate, filter, join, all right there on your laptop instantly.
And then you can just email the resulting database file to your boss.
Right. It's the ultimate data scratch pad. You don't need to file a ticket with IT to get a database instance. You just make one on your desktop, do your analysis, and delete it when you're done. It empowers the individual.
That word empower feels right. It really democratizes the power of SQL. You don't need a budget, you don't need a server, you don't need permission, you just need a library.
It just removes all the friction between I have an idea and I have structured data.
So let's bring this all together. We've gone from the U.S. Navy to the Library of Congress. We've debunked serverless and realized it's just a C library making function calls. We've marveled at the single file portability, the fact you can just drag and drop a database.
And we've figured out that while it's not for the next Facebook with wall mode, it's more than powerful enough for 95% of the apps most of us will probably ever build.
It really is the Goldilocks solution. Not too big, not too small. But I want to leave our listeners with one last thought. We spend so much of our lives now in the cloud. Our photos are on iCloud, our documents on Google Drive, our code on GitHub. We think of data as this abstract thing that lives out there.
We've sort of lost a sense of digital object permanence.
Exactly. But SQLite is a reminder that data can be physical. It's a file. It's bytes on a disk that you own, that you can copy, back up to a USB drive, and I don't know, bury in the backyard if you want. In a world of subscriptions and APIs that can be shut down tomorrow, isn't there something radically rebellious about a database that fits in your pocket and requires no one's permission to run?
It puts the ownership of data back in your hands. And in this digital age, that's a rare and incredibly powerful thing.
Something to think about the next time you write import SQLite 3. That's it for this deep dive. Thanks for listening.
Keep exploring.